Hi, seventh graders. It is day one of our ninth week for quarter two. Next week is the last week. All right, so last week we did one step of adding and subtracting rational equations. So what we are going to be focusing on today is using multiplication and division one-step equations. So as you notice here, we have a one-step equation with an integers. There is negatives. Okay. Eventually, we are going to be doing two-step equations and one-step equations with rationals. We need to master down these skills. Okay, this is still Unit 3 and in Chapter 6 of our textbook. This is our fourth lesson on equations, if you're keeping all your notes organized in your notebook, which today's notes will go in after last week's notes. Okay, some of these can be hard to handwrite, so if you need to print out the notes first so that you have them ready to go. All right, so remember, an equation is like a scale. Remember we talked about the scale being where you are balancing how much does this side weigh when you put this over there. So we need to maintain our balance on both sides. Therefore, whatever you do on one side of the equation, we always have to do to the other. And so we kind of treat this part right here is like our equal sign. Okay? That's what we think of it. So whatever we have on one side, we are definitely doing to the other side. Okay? So we do have our first example that we are going to do, and there is modeling with this. So you need to make sure that you understand how we are going to model and where I am getting my information. Okay, so the equation we're going to do modeling and the algebraic way, because you have to be able to do both. Okay, but the algebraic way is what is going to be the main part for iLearn and for when you get to larger grades where you're going to have to model your work. Okay, and so what I have here is we are going to start with putting x's on each side. Okay, so it tells me I need two x's. So I already have one x started, and then I just have to put my other x. That models this side right here. And then it says I need 10 ones, or we can use our positive sign because it's a positive 10. Okay. There is 8, 9, and 10. I'm going to do this side a little bit sloppy. Okay, just so that you can kind of be like, ooh, well, how is this really going to work out? Well, I have to split how many x's go with our first x and how many x's go with our next one. Then I notice, oh, well, I have 2 additional pluses floating around, not in anything. So I actually need to put these with the others. And then I'm going to delete these. Makes it easier if you already have it all split up, because then you can tell how many are going with each x. So then if I count, I have 1, 2, 3, 4, 5. I have 5 x's that represent each one. So we would say that we do know that x equals 5. Now remember, whatever you get in your modeling should be the same thing that we get when we go here for algebra. Okay. Now if you need to pause this to catch up your modeling, do so. Okay, so going to the right side, we have 2x equals 10. Remember, our job is to isolate and find out what is 1x worth. So then I see I have multiplication. Well, just like with addition, what was the opposite of that? So we use our inverse operation of division. Okay, that's what we have to use. So to show that, I'm going to divide both sides. Change my color so it stands out a little bit more. Both sides are going to be divided. So there's my division. But then I'm going to put the same number inside both of these. Well, what number is with my x? My 2. That's what I want to get rid of, so that's what I divide by. It doesn't matter that it's on the left side of the equal sign. It's what's with the variable, so that's what I want to get rid of. Okay? And then we divide. The reason why we divide that is so that when I come over here, what's 2 divided by 2? They make 1. They cancel each other out. That's the whole point of it. Because then I'm only left with x. And then what is x? Or x equals, we're just left with our equal sign. And what's 10 divided by 2? 5. Now, as always, remember, always check our work. And the way we do that is we take what we were found the variable to be and multiply it into the equation that we have. So I would need to know, is 2 times 5 the same as 10? Well, yes, 10 does equal 10. And that's how we solve that one. Okay, you need to pause this and then come back. And then we're going to look at our next one. I have 3x equals negative 12. Okay, so we want to know, how are we going to solve this? Well, I have my 3x's first. Okay, I need to find out how many negatives are going to go with each one. And if you notice here, I have my 1x, and each x is getting 4 negatives. And that's because I did it nice and neat. Ooh, kind of cut that one out. If you didn't have it nice and neat, you could literally sit here, make your spaces, and put negative, negative, negative. Each one gets a negative until you have some left over. So how do I solve this algebraically? Well, remember, we want to get rid of what is with my variable. So I want to get rid of that 3 by dividing by 3. Now, this is where you have to remember your integer rules. Okay, I'm dividing a negative number here by a positive number. Different signs gets me a negative solution. So my answer is actually x equals negative 4. Okay. Then we check our work as always. Plug in what I got for x into my equation. And I get that 3 times negative 4. Oops, I forgot my negative. And make sure when you check your work, you put everything in the exact same as how it was. Okay? That happens. Remember, that's your baby sister that you want to bring home from the grocery store. All right, the next one we have negatives. This gets a little tricky. All right, my answer is not x equals a positive 2. I got to get rid of these negatives. So to get rid of them, we have to do the opposite of what we have over here. So to make this a positive, that's really like multiplying it by a negative 1. Okay? That's how you get your positive. So then I have to turn these over here, these positives, have to become negatives. So I'm going to even make this a little bit thicker so I can go over my negative positives. It's really a negative and a negative. To make this a positive, I make this a negative and a negative. We want this to be a positive. So negative and a negative. We got to change it to do the opposite of what it was. Because I changed the left side, I have to change the right side. I just can't keep them all positives. Okay, and it's negatives because that's what we have. We have 4 negative x's. And then I had to change that. So then what does each one get? What is inside each of these? Well, this x got 2 negatives. This x gets 2 negatives. And vice versa. So if you notice, all 4 have 2 negatives in them. So when I go to solve this over on the other side, I should get the same thing. All right, so let's see. Do I get the same thing? I need to divide both sides. So I put my division symbol. Then what is with x? What am I getting rid of to get x by itself? Well, my negative 4. I'm going to divide both sides by negative 4. That makes this actually cancel out because a negative 4 divided by a negative 4, we know, makes 1. So those cancel. That's the whole purpose of it. So then all that's left is to take my x equals and divide 8 by negative 4, which gives me a negative 2. Then as always, check our work. Okay. Well, I'm taking a negative 4, wrong symbol, and multiplying it now by a negative 2. All right. Do you remember your integer man? 2 negatives will make a positive because this negative here, this negative means to do the opposite of this negative. So then does 8 or negative 4 times negative 2 make 8? Yes, it does. So we are good. We got everything we needed. All right. All right, so an inverse of operation of multiplication is, as we said, division. Okay, so if you need to, fill that in. And then we're going to go to our next page, which has some division. All right. So we have 1x over here. That's what we want to find out. And in each half is a 4. And this half is a 4. Okay. If I wanted to model, I could put let's do it with more of a, correct this down. And because they are positives, I'm putting 4 positives in each one. And the reason why we said a half is because that's what the other side is. It's saying only half of an x is equal to 4. Well, if you bought a whole pizza, you want to know how much that whole pizza costs, right? Not just half of it. So that's where we have to put it together, and we find out that x actually does equal 8. Okay? So then I need to do this algebraically. Well, what is the opposite of division? Multiplication. So we're actually going to multiply on both sides. Using the dot, because we have variables, we don't want to use an x. We're going to multiply both sides by what is x being divided by, because we want to isolate our x. We want to multiply both sides by 2. Because remember, I want to get rid of this 2, and 2 over 2 makes 1. And whatever I do to the left side, I've got to do to the other side. So then all I'm left with is my x on the left, and then I just have to take what is 4 times 2, 8. And then as always, check our work, okay? Well, if we're saying we have 8 divided by 2 is our equation, so the left side needs to equal the right side. We want to make sure we get 4 on both sides. Well, what's half of 8? Well, 4. So yes, our solution is true. So we are correct with our value of x. If you need to pause that, go ahead. Our next equation is x divided by 3 equals a negative 5. Oops, I think this is supposed to be a 5 over here. Fix this to a 5. Okay. So say you're buying some type of little lovely tool. Take a candy bar. Okay. You will have to spend $5 for 1/3 of this candy bar. But what if you want the whole candy bar? You don't just want a third of it. How many people go in the gas station and only buy a third of a candy bar? Okay. So we want to find out how much each section of that candy bar is. Well, if you wanted to buy the whole thing, you would get x equals a negative, oops, 15. Okay. So our job is to find out how much is just 1x. And so that's why we say when we come over to do it the algebraic way, the inverse of division, you said, is multiplication. So I want to multiply both sides by 3 because then these cancel. Okay. So then I'm only left with my x on one side. And then I just have to take a negative times a positive gives me a negative. And 5 times 3 is 15. Okay. And then as always, we want to check our work. Take your negative 15, replace your variable with your solution. That's how you check your work. Not just by putting a check mark or just putting negative 5 equals negative 5. You have to actually rewrite the equation with the variable replaced with its solution. How you check it. Okay, so then a negative 5 divided by 3, and if you need to, use the calculator to check this. That's a tool. If you're not very strong with your math facts, use something to help you to check your work. Now, you still have to write what you're doing, because otherwise, if you missed it in the top part because you weren't very good with your math facts, strong possibility you're going to do multiplication still wrong when you're checking your work. If you need to, pause that one. Then we're going to come back to the next one. X divided by a negative 4 equals negative 6. So how many parts of a circle do I need? I need 4 parts. Okay. So here is my 4 parts of a pizza. The small pizza split into 4 parts. I want to know how much for 1x, the whole thing. I want to buy the whole pizza. I'm not just buying a quarter of it. Okay. Remember, if you're dividing by a negative, that means to do the opposite of what we have here. So I actually want to put 6 positives inside each of these. Okay, so if I had my counters, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And because I'm using blue, I know they're positive. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, if I went through and counted how many 6 positives do I have in total? Okay, 6, 12, 18, 24. So X is 24. Okay, that's where you have to remember those integer rules. Okay, so even when I come over here to multiply by my -4, and I do that so that these cancel. Well, remember, a negative and a negative make a positive answer because you are doing the opposite of what you have on the other side. Okay, so what would we say is the inverse operation? Multiplication. We can isolate the variable in multiplication or division equations by using our inverse operations. Okay? Because multiplying reciprocals give you a product of 1. The whole reasoning why we do that. Okay, so next we are going to do some guided practice. So if you want, do this in your textbook, page 450, volume 2. Okay, I am going to do a couple, well, 3 of them with you on one side, and then you're going to do the others on your own and check your work. Okay, so for number 1, I notice it's multiplication. So the opposite of multiplication is division. So I'm going to put division. Remember, fractions are just division. That's all it is. And then I'm going to come back and decide, what do I want to divide both sides by? Well, what's with the variable? My variable c, and 6 is with the variable. So that is what I divide both sides by. Full reasoning, because then these cancel right there. And all I'm left with now is just my variable c, and then I divide 18 by 6 to get 3. And then obviously we come back and check our work. 6 times 3, is that going to equal 18? Well, if I borrow $6 3 different times from you, yes, we get 18 equals 18. Okay. Let's look at problem 4. Now, sometimes they don't give you as much space to write what you're multiplying by. So if you need to, you can rewrite the problem. But if it's a small enough number, you can squeeze it in over here. Remember, whatever you're multiplying both sides by, for one side, you have to multiply the other side. I want to get p by itself, so that's why I chose to multiply by 9. And remember, a reciprocal is taking what you're given and flipping it over. So that's how I know 9 divided by 9 makes 1. And 1 times p is just p. And then we keep our equal sign, try to line them up the best you can. And then all I have to do is take my 9 times 9 to get 81. Okay, so then I just need to check my work. All right. Well, if I'm checking my work, I'm replacing p with my 81. So 81 divided by 9 is that going to equal 9? Notice these are all positives so far. When you get over here, you're going to have to watch out for those negatives. Well, 81 divided by 9 is 9. Bada bing, bada boom, we are correct. So number 7, one word problem. I'll do one with you and then you'll do the other. Antoniana earns $6 per hour. Per is one of those keywords. It tells us we're going to be multiplying here. When she's helping her grandmother, write and solve an equation to find out how many hours she needs to work to earn $48. Okay, well, we don't know how many hours, so that's going to be our variable. 6H equals, and she wants to earn $48. There's our equation. That's one part of what they want us to do. The next thing they want us to do is solve for H. How many hours is she going to work? Well, we want to divide because we're multiplying and the opposite of multiplication is division. So what am I going to multiply or divide by? Well, is my H over here? No. Here's my H. I want to divide by 6 because that's what's with the variable. And the whole key is to find out what the variable is as just one of that variable. Divide by 6 because then these cancel. I'm only left with H. And then how many times does 6 go into 48? It goes in 8 times. So what's our answer? What does that H represent? Okay. Toniana will need to work 8 hours to make her $48. Okay. All right. I want you to try the other 5 problems and then check them. So pause the video, then come back and check your answers. This is a great way to see if you really understand this. All right, so hopefully you've had a chance to do your work and you've come back, and let's see what I have. For 2, I got x equals -3 because I divided both sides by a -8. And for 3, I got m equals a -4. So I divided by 7. 5 and 6, they are division, and the opposite of division is multiplication. So then I got that a equals a -36 and an n equals 40. Number 8, another word problem. A shark can swim at an average speed of 25 miles per hour. At this rate, how far can a shark swim in 24 hours? So they said use rate equals distance divided by time. Okay, our rate is the 25 miles. So that replaces my R, and our time is the 2 4/10 hours. So here was my original equation in the colors. And then I multiplied both sides by my 22.4. Because then these canceled. Then I only found out that D equals 60 miles. So the shark can swim 60 miles in 2 4/10 hours. Let's talk homework. All right, you are doing the next page. Well, pages. Okay, you have 451. You're doing 1 through 15. So that's not too many problems. Okay, so let's go through a couple. I will do a couple with you. So here we have multiplication. So as before, the opposite is division. So if you notice, all of these right here are multiplication. So we know we're going to do division with all of those. We just have to figure out what we're going to divide by as well. Okay, well, what letters with the variable? My variable is A. I'm going to divide by 7. Remember, you want to isolate. No, you cannot just sit here and write 8 equals 7. You have to be showing your work. I don't care which teacher you have, we all require for you to show your work. Then we also require for you to come back and check your work. Okay, so A equals 7. So if you need to, use the little space you have over here and check your work. Let's check it. What is 7 times 7? Is that going to equal my 49? I check my multiplication chart, and yes, I get 49 equals 49. That's what we're looking for. That you know which operation you're using as the inverse operation. You know what you're dividing or multiplying by. What is your solution? And checking your work completely. So it's like 4 steps you need to make sure you're doing for each of these problems. Okay, let's look at number 4. You have u divided by 6 equals 9. Well, obviously, what do we want to get rid of? This 6. So we're going to multiply both sides by 6. Like I said, if you don't have enough room, rewrite your whole equation so it doesn't look sloppy. Luckily, I can zoom in and I can make it fit. And the whole reason why we do that is so that this reciprocal of 6 cancels out the other 6. That's the whole purpose of it. So then we get that u, oops, get rid of that. We'll go with text. We now know u equals, and then 9 times 6 is 54. Well, now I'm going to come over to my other spot. This is my 4th step. I already identified and multiplied. I identified what I was multiplying both sides by. I gave my solution, and now I'm going to check my work. Is u 54 divided by 6 equal 9? In this case, yes, it is. We get 9 equals 9. Okay? Try to keep your work as organized as you possibly can. Okay? And then if you get any other questions, please reach out to your teacher to get any clarification. But these should be fairly simple. You are either multiplying or dividing on all of these. Okay, so do the opposite of what you see. You see multiplication, even though that x is on the right side, I know because x has this 2 attached to it, I'm going to divide by 2. Okay, and then solve and check your work. Number 5, even though c is on the right side, I want to get rid of this negative 10 that is with it. So I'm going to multiply both sides by a negative 10. It does not matter what side the variable is on. Whatever number is with that variable on that side is what you're trying to cancel out. Okay? Make sure you show your work, check your work, and then if you did this in your textbook, make sure you are submitting a very visually clear picture of your work, even if you have to do it in 4 different pictures. We want to be able to see how you are doing on this. All right, have a great day.